public thing here in the building. So thanks for making it a full crowd. It had been kind of disappointing if there was like 4 people here today. So thanks everybody for coming. When talking with about AI, I think it's useful that we have good terminology that everybody uses the same. AI is, generically, it's just simulating human intelligence to solve a problem with a computer. And then you hear people talking about machine learning, and that's just basically using data to train and search for other data if you want to get down to a basic level. Deep learning just takes that up to another level and uses multi-layer neural networks to analyze patterns instead of just single things. Neural networks are computational models inspired by the human brain. Computer vision uses cameras to make decisions and identify patterns. And this is all different types of AI. So when people start talking about AI, they can mean a number of different things. And a lot of these are encompassing smaller items. So for instance, large language models, which we'll talk about here, is a type of generative AI, which is a type of deep learning, which is a type of machine learning, which is a type of artificial intelligence. So when we start throwing these terms around, it's useful to know how they all work together and are used. What most people have been talking about over the last 6 months to a year has been generative AI. And that's artificial intelligence that creates original content. Text, images, music now. It's kind of some weird music if you've heard what the AI music, it's like good but not at the same time. Like, it's hard to put a finger on. A large language model is a model trained on text to generate human language. And it is one of the things I want everybody to understand about these large language models, these are not new. We have been using these for well over a decade right now. Anybody that has a smartphone that has autocomplete, anybody who has ever started typing in stuff into Google or a search engine and had it autocomplete the question, that is a type of large language model. What has changed is the complexity of the model and how they're used. Because historically, these large language models were only used to figure out what your next couple words were going to be. And then one day somebody got the bright idea to ask the large language model a complicated question, and it gave the correct answer. And from that, that's kind of where all of this large language model work has exploded out of. But when it gets right down to it, at the core, these large language models are nothing more than just autocomplete on your phone, just taken up to a whole nother level, and then again, and probably another one then again after that. Transformer model, these are neural network architectures that process data in parallel. This is what your large language models run on. And then a token is the basic unit of text that a large language model processes. Whenever you work with any of these large language models, there will always be some place where it'll tell you how many tokens you used, because that's how they bill. If you're using ChatGPT, the free version, you have a limit to how many tokens you can use in a day, or maybe it's a month, I forget which, but there's some sort of a limit. And if you're paying for it, you're limited. If you have a subscription plan, you're limited to how many tokens you can request as part of your subscription, or you're actually billed per token. One of the ways that you can use ChatGPT is if you go out and you buy like 2 million tokens, and then they bill you for those 2 million tokens, and then you just use those up, and then they bill you for another 2 million tokens or something like that. And that is not what a token looks like. I always think that's funny because people think a token, what is that? You can touch it. No, it's not a token. Not something you can touch. When we start talking about large language models and how we interact with them, the first thing that everyone sees is a prompt, and that's the query or instruction you give a large language model. What I'm going to be spending some time at the end of this discussion today talking about is something called prompt engineering. And that's writing better, that's useful because it helps you write better prompts to get better output. So basically helps you get more out of the large language model than you would otherwise. People will say that large language models hallucinate. That's just a fancy way of saying it gives you bad information. A classic one that large language models have a hard time solving. If you ask a lot of these models how many R's are in the word strawberry, usually they tell you 2. And that's kind of like a way to tell if you're using an older large language model or a newer one, is if it tells you correctly that there's 3. So that's what hallucinations are. And the context window is the amount of tokens that a large language model can consider at one time during a conversation. So when you interface with ChatGPT, you have a window, and you start conversing with the large language model in that window. And that window has a maximum token length. And when you hit that maximum length, it can't handle anymore, and it has to start all over again. So we want to fit what's useful in the context window and get rid of everything that's not useful in the context window. There are a lot of generative AI tools on campus and just AI tools in general. So the website on campus that has all this information is genai.illinois.edu/AI-apps. Everybody has Copilot Chat. This is free. This is included with your Microsoft license. It works best with Microsoft stuff because it's a Microsoft AI. So if you need to summarize an Excel documents, if you need to summarize Word documents, help you write text in Word, Copilot Chat's very good for that. ChatGPT, that's what everybody is most familiar with when you start talking about AI. There's an educational version of that costs $11 a month. You can get it through the campus web store. It's very useful for writing, research, complex problem solving. I do not write an email that goes out to the building without sending it through ChatGPT first, because I am an engineer and not an English person. I need help writing. I use ChatGPT for that. Google Gemini is included for free. Campus has a Google license. We have that. It's useful for brainstorming, content generation, general Q&A. There's a service that I'm going to demo later on called BioBot that I've made in the building here. It's not quite ready for prime time. It's got a few problems in the next week I'm going to fix. But it's going to be available to the building as well for free. Currently, we're using it has 2 models that primarily on there that we're showing to people, and that's Llama 4, which is a large language model developed by Facebook, and Qwen 3 Coder for code analysis. It's useful to know that for this, none of the information goes back to Facebook or the people who made Qwen. Because it's hosted locally, all the data stays here in the building. It never calls, that data never leaves the machine you send it to. So why are there only these tools? There's a lot of reasons. A couple of them are data privacy and security. Whenever you send data to an AI model, that data is going to be used later to retrain that AI model to get better results, which sounds great. Why would you not want that? Well, if you found a cure for cancer and you wrote about it a lot and you sent it into ChatGPT, you don't want anybody, accidentally getting the ChatGPT to spell out all of your life's work in a prompt back to somebody else later, or even pointing them in the right direction even. So you want to keep that safe. That also intellectual property, who owns what. If you start giving it away to ChatGPT, you want to make sure that they don't try to own it. Regulatory compliance. There are so many MOUs and NDAs and all sorts of legal stuff that we deal with here on campus that, we need to be careful what data we're sharing with what people and how. So whenever we use these AI tools, we need to care about that. Another one is ensuring accuracy. Some models developed in China specifically have been manually edited to remove certain keywords and terms. We want to make sure that whenever we use models that they don't have any sort of implicit bias that's put in there manually. All models will have some sort of bias because the data you train them on has to be biased in some way, shape, or form. But whenever people go in and manually do that, that's not good. We don't want that. Another one is power, but we'll get into that a little more later. So these are if you want to know what AI hardware you have available to you right now, and this is for everybody. Certain people, like if you're in CABI, you have extra resources that CABI has paid for. But everybody in the building has access, can get into BioCluster. BioCluster has 6 A40 GPUs. Those are good for inferencing. So if you have a model that you want to query, and it'll fit in the memory on an A40 GPU, that's a good tool for you to use. BioBot, which we'll talk about more in a minute. We have 2 evaluation systems. We have one system with an RTX Pro 6000 that will soon be available. I made a mistake setting it up and I didn't install the drivers properly. That's why it is not currently available. I have to go back and fix that. And we also have a DGX Spark, and that's that little system over there on the right. The picture is a little deceptive. This system is about the size of a Mac Mini. And if you need, if memory in your GPU is what is important to you, this is a great little system. It doesn't have quite as many CUDA cores as an RTX Pro 6000, but what it does have is 128 gigabytes of RAM. And that is a lot of RAM for a little system. And these are only $5,000 a piece, which is a lot of money, but when you're talking about these AI tools, that RTX Pro 6000 is $8,000. So the DGX Spark is a deal, and it is small. It'll fit on a desk. You can use it anywhere. You can put it in your backpack, take it from place to place. It only pulls 300 watts from the wall. It's a great little system if you're doing a little bit of AI research and getting started. There's also Delta AI. That's the big AI tool on campus that's run by NCSA. As part of the University of Illinois, you can get an account there. They have large numbers of high memory GPUs. But I also want to be clear that if you want to build a huge large language model, even Delta AI is not big enough for that. So like the models that ChatGPT is being built on, these are in data centers the size of Memorial Stadium. They are huge. They have water pumps in them, the size of the same pumps that are in fire trucks. I was at the big supercomputing conference this year called Supercomputing 2025, and it looked more like a plumbing convention in places than a supercomputing convention because it was all about pipes and water interconnects and things like that. Come back, please. There we go. So Delta AI is a great tool, but it may not be the if you have really high needs, it still may not be big enough for what you need. Campus Cluster has some GPU resources, mostly for inferencing. I wouldn't really call Campus Cluster a GPU resource. It just has some. It's kind of the same as BioCluster. BioCluster isn't primarily a GPU resource. It just has some. And then lastly, commercial, that's what I was talking about earlier. If you're creating a large language model from scratch or have a larger AI application, you might need to purchase time from a dedicated AI factory. That's what they call them. I don't know why they call them a factory, but that's what they call them. That is not cheap, but it is also the only way to do that type of work. So, kind of moving forward, we talked a little bit about prompt engineering earlier. And here's some basic tips on how to get more out of your large language model. The first is to give the AI a role. So for instance, you are an expert writer. You are a award-winning biologist. Tell it what it is. And then it will usually say something stupid like, "Great, thanks. I'm glad glad you think that about me." But that basically trains the large language model. It partitions out what type of information it's going to pull out for you. Then you give the AI a task. Write, summarize, analyze. Give context, provide details, give documents, web pages. For instance, in the large language model that we have, if you ask it what the IGB is, it will not tell you we're the Institute for Genomic Biology. But because there's a dozen different orgs that have the initials IGB, and we just aren't big enough to be number one on the list. However, if you give it the IGB's webpage, it will give you a perfect answer. So there's a place where you can add in web pages and stuff like that. That's all useful. Give the AI input, actually give it the request that you're trying to get the AI to answer. You can define the output format as a table, give me a bulleted list. Use chain of thought. Whenever I write emails to the IGB, I always mess with it until it helps me get everything worded like I want it. And then the next thing in my chain of thought is make it more concise, because nobody's going to read a book. So, things like that can really help your large language model results and how they go. And then lastly, gain experience. The best way to learn it is to use it. One of my best examples is whenever I write an email. So I've been using BioBot for a month or two now while I've been playing with it. If I enable the web search feature on it and I try to write a email that I'm going to send to the building, it will never give me good results. But if I go in and I click off the feature where it searches the web, then it gives me exactly what I need every time. So you just need a little bit of that experience of what to use and what not to use and how to help stuff out with stuff, right? So I will go ahead and start, went too far. I will go ahead and start off with my demo here. So this is BioBot. It is not ready for prime time, and you can tell that by the not secure thing in the browser up there. I need to get an HTTP proxy set up so you can't sniff passwords when it's sent to the system. But it'll work with my dummy account today. So my son is 20 years old, and he has a birthday this month. So let's use BioBot to try to help figure out what I want to get my son for his birthday. So first, prompt engineering, we need to give it a role. You pick the best birthday presents. It's also useful to see right here. So we have web search turned on, and we also have this image system turned on, which doesn't really matter. You can also go into here, You can also go into here, and you can also turn on a code interpreter if you want to, but we don't need that right now. So you pick the best birthday presents. And then BioBot, in a minute or two, will come back and say, gee, thanks. All right. So then we write something like, can you pick a good birthday present? Let's do 5 birthday presents for a 20-year-old man who loves airsoft. Airsoft is like paintball, if you don't know what airsoft is, where you run around and shoot people in the woods. My son loves airsoft. So you give it a minute, and then it comes back, and then it gave me some choices. An airsoft gun, an airsoft accessories, airsoft protective gear, airsoft tactical gear, blah, blah, blah. And then you look here, and there's this information here that's useful. One, it tells you where it looked to get these resources. You can look at it right here. And then You can have some other choices for questions. You can see how many tokens you've used by highlighting over here. It tells you what all the different tokens are you've used for everything. And then, so let's refine this a little bit. So what if he is a kinesiology people? I'm sorry if I spelled that wrong.
Hey Dan, can you make it a little bigger?
Sure can. And I did that wrong. Oh, so unique ideas for kinesiology and airsoft. You know, the biomechanisms of airsoft movement, because my son's a kinesiology major. Book on sports science and airsoft strategy. A fitness tracker designed for athletes. You know, this is how you refine your prompt. So this is just an example. We also, I mentioned earlier, we have Quinn 3 Coder, and I didn't test this today, so let's watch this break. Actually, let's start a new session. So this is important too. Whenever you change topics, open a new chat. Otherwise, you're poisoning your chat with your prior conversation. So let's switch over to Quinn 3 Coder, and you can say, let's see if we can write some Perl code, some Python code, to, what would be a good thing to use Python code to do? Search, let's make it simpler. Calculate the area of a circle. And we'll see if it does it. Now, the first time you run one of these, if you look up here, you can see whenever you click up here in this drop-down box, there's a green dot by some of these and not. The green dot means the model's already loaded into memory. If the model's not loaded into memory, you need to give it a minute, and eventually it will spit out the information after it pulls it down into memory. But this takes a little bit. So look, it says analyzing now, which means it's loaded it, and it's going to disappoint me and not do anything. There we go. How would you modify the code for the radius? How do you? Okay. I'm going to bail on this because I didn't test it beforehand. But ideally, this is more made for you to put code into and have it analyze it and not have it spit code out. You can also turn on the code interpreter in. So we can go in here and switch this from Quinn 3 to Llama 4, and we can go in here and turn off the web search and code interpreter on. Try it again. See if it does any better. There we go. So, like this is a great example, and it ran through it way too fast for anybody to read it. But the point is it actually gave us some Python code, told us what module, what library we needed to have, and then gave us some good coding qualities, like we have comments. If you write code, please put in comments. I can't tell you the number of times we've had grad students or postdocs leave, and I have code that has poorly defined variables that are like variable 1, variable 2, variable 3, and no code, and people are trying to get us to fix that. Please write comments. Please use really good named variables. But like this is an example of what you can do with an AI. I would highly suggest that you not just rely on AI for generating your code. AI is great for reviewing code, for offering suggestions, helping you think about your code a different way. But if you're trying to write a program that you're going to rely upon for like a thesis or something like that, do it yourself. Don't just rely on the AI for it. It will always come back to bite you. Right? Any questions? Going once? Going twice? All right. Well, lastly, I just want to mention to everyone that AI is always getting better. This Llama 4 model that I've been using, it came out last year, so that means Llama 5 will come out any moment now this year. And I'm sure it'll be a bigger model, it'll be a better model, but to show you the change, there is a classic thing of somebody used AI to make a video of Will Smith eating spaghetti. And this is the original version of that. This nightmare fuel right here is just horrible. And the new version that I'm going to show in a minute is not that much better. But as you can see, it is better it is better. Be thankful the sound doesn't work. It has some sort of like slurping noise on the new one. Like, it didn't like that at all. So this is the new version of Will Smith eating spaghetti. And notice how it's still not great, but it is way better than what it was. This is less than 3 years ago. This is 3 years of advancement with Nightmare Fuel. So, again, just realize AI is always getting better. I don't think AI is going to be taking anybody's jobs, but I will think it'll allow people to do more, and I think it will allow people to make less mistakes. That's where I think AI is going, is more productivity and less mistakes. But with that, I am done, and any questions? Yes.
So you said when you were showing the bot,
Yep.
GB bot, and it said it took a minute to load the model.
Yep.
Is that talking about the model that has like the millions and millions of variables?
Yep.
That would produce
Yep.
the next word of the thing?
Well, there's so you can think about a GPU kind of the same way you classically thought of a computer, right? You know, you have the processor, and then you have RAM, and you have the hard disk. So in order for the GPU to analyze anything, it has to be in RAM and not on the hard disk. So what it pulls that entire model, which is basically it's just a bunch of numbers, to be honest with you, and it puts it all into the memory of the card, and then once it's in the memory of the card, then it can start analyzing your question. So there's some period of time where it has to drag that data off of the disk and into the RAM, and that's what takes some time.
But in this case, you're interfacing with it through your own computer, whereas if I go to, is that right?
Yeah.
Whereas if I'm using ChatGPT, I'm going through a browser.
Yep. Well, both of them are through a browser, but the question is where's the computer that you're interfacing with through that browser located? And that computer is around the corner in case of BioBot, and that computer is in some data center somewhere when it comes to ChatGPT. Yes? So right now the answer is I'm planning for it to be free. Then again, I'm only here for a little bit more longer. So what everybody else does whenever I'm not here is kind of out of my control. I do think this should be a free resource, though. It's not cheap, but it's also not horribly expensive at the same time. So, I mean, we never know what the future holds. So never say never, but I think it should be a free resource. Currently free, yes. Currently also not available, really. But that will change sometime in the next week. Yeah?
So this was a really good talk because it's helping me understand the science behind AI. And I saw a talk about this last week where they were saying that, and they reiterated what you said in that it's really just, it's autocorrect, but the advancement that is possible now is that the computational speed is high now.
Yeah.
And also that just the information in the world that this thing could pull from the internet
Mm-hmm.
to get the database of that size.
Yep.
And so is that a good understanding?
Yeah, that's a really good understanding. The keynote speaker at Supercomputing this year had a chart where he showed how x86 computing had plateaued. Used to, the computer that you bought today was 1,000 times better than the computer you could buy 10 years ago in terms of what it could do. Today, it's only 4 times better than the computer you could buy 10 years ago. That's a huge difference. That's why it's not all that important for people to upgrade their desktop computers anymore for the most part. Huh? Yeah. But that's just the way things are going. So this is why GPU and GPU-based computing has really thrown itself into the front, is because that's another way to keep the processing power growing at this accelerated rate of 1,000 times in 10 years, and that's where we are right now. He also mentioned that had a graph of the amount of data that was stored and projected that into the future. And in 100 years, if the amount of data stored keeps growing at the same rate, there will be more bytes of data than there are atoms in the solar system. So you can think about that, and what that means is that at some point in time in the next 100 years, we're going to have to figure out what we're going to do with all of our data, because we can't keep it all. Because you can't, there aren't enough atoms. And unless we figure out some way with quantum computing or quantum storage to do it, we're going to have to do something different. Yeah.
I have a follow-up question to that.
Yep.
So, this is just for my own understanding. If we took all the writings that were published, for lack of a better word, all the books chronologically and line them up chronologically, when would you have enough data to make a chatbot that can do what?
I have no idea.
Okay, so where I'm going with this is, if you trained a model only on stuff up to 1930,
Yeah.
would it be able to predict nuclear power,
Maybe.
physics, modern physics?
I don't know. That sounds like a research proposal. What I think is kind of the more common question that we're going to be with. So I talked about Llama version 4 today a lot. Llama version 4 is quite a bit better than Llama version 3, which is what I've been playing with before, which is what I was playing with early on. When Llama 5 comes out, I don't expect it to be as much better than Llama 4 as Llama 4 was from Llama 3. There's diminishing returns, and there's actually a graph that shows this. And unless the way that we make large language models change, sometime within the next 10 years, the next version is just not going to be worth the effort, because it's going to get to the point where year-old AI is pretty good, and the newer AI still has many of the same problems that the year-old AI has. Unless something changes, that's kind of where we're headed.